Good day. So this is our now lesson for language and mathematics. In our previous lesson in functions, we discussed how we are able to model uh, phenomena from the real world and then put it into a mathematical expression, which was using functions. So what we are going to do now, we are going to translate other sentences that involves some quantities in them into mathematical expression and vice versa. So from mathematical expressions, we would be looking into how we would be um, expressing them in conversational English. So let's have some examples. We go first to the most basic operations that we have, which are arithmetic. So arithmetic, of course, we would have addition, subtraction, multiplication, and division. So in this expression, of course, we would read that as x plus 1. Other ways that we can express that expression is 1 is added to x is added by 1, x is increased by 1 more than x, or since we are doing addition here, the result of addition is the sum. So we say the sum of x and 1. Now notice the order that we have here on this two. 1 is added to x, but we say this as x is added by 1 or x is increased by 1. So the first thing that we have here is x. And how we write that is 1 is added to x because 1 comes after x. So that's why our preposition here is to, or the complete prepositional phrase is added to. So 1 is added to x because 1 comes after x. In contrast, the second phrase that we have, x is added by 1 or x is increased by 1. So in waray-waray, we can think of it as he x gindugangan hin 1. The first phrase that we have, he 1 gindugang kan x. So that is exactly why we have x plus 1. So our use of prepositions, the proper use of prepositions here is significantly more important when we look at non-commutative operations. So when we say commutative, we can interchange the order. So we know that x plus 1 is just the same as 1 plus x. These two would yield the same thing. However, when we have subtraction, x minus 2 is not equal to 2 minus x. So how we interpret this is important. So of course, x minus 2, that's the way that we would read this expression. So we can also read that as x subtracted by 2, x decreased by 2. Now, this is the second, this is the important part. We say 2 is subtracted from x, or 2 is deducted from x. So in waray-waray, we can think of it as hito ginkuha tikang kan x. So the order x comes first and then 2 will come next. Because again, hito ginkuha tikang kan x, or he x ginkuhaan hin 2. So x minus 2 would mean either of those phrases. But then again, no, as I mentioned, the usage becomes important. If we write here x is subtracted from 2, then the way that we write this in mathematical expression, it should be 2 minus x. He x ginkuha tikang kan 2. So that is 2 minus x. Other ways that we can write this, we can use reduce x by 2 or x less 2. And of course, when we have subtraction, the result is called the difference. So we say the difference of x and 2. So now we have multiplication. So how we understood this from algebra, if you have a constant and a variable and you multiply them, you don't need to write the multiplication symbol. So you just put together, or you put side by side 3 and x. So In algebra, we just simply read that as 3x, but of course, since this is multiplication, so we can also say 3 times x, or we can also say thrice x, three folds x, x increased three folds, x increased thrice, or x increased three times, or you can also say triple x. Or again, since this is multiplication, the result is called the product, so we say the product of 3 and x. Then we also have division. So we read that as x divided by 4, or we say x divided into four parts, or x is split into four parts. We can also say x is distributed into four. Now, please remember when we had our discussion on the golden ratio. So, golden ratio, if you remember, we divide certain numbers or we divide uh, consecutive numbers in our Fibonacci sequence, and we are able to get the golden ratio. So, ratio here would mean ratio would imply division. So, x divided by 4, we can also say the ratio of x and 4, or again, since this is division, the result is called the quotient. So the quotient of x and 4. Now let's look at the exponents. So for exponent 2, we say x squared or the square of x. X to the power 3 or x exponent 3, we say x cubed or the cube of x. So if our exponent is 2 and 3, then we have the special names, again, the square and the cube. So any other exponent, we can just say x raised to n or x to the power of n. Now let's look at other ways that we can express multiplication. So if we are multiplying by 2, so we can say twice, double, two folds. As we have seen, multiplication by 3, we can say thrice, triple, or three folds. Multiplication by 4 is quadruple, four folds. Multiplication by 5, quintuple, five folds. Or any other multiplication, we can just say n folds. Of course, some people would use six folds or hextuple for seven, heptuple, and so on, but those are rarely used. So the easier way for us to do that is just by using n folds. Now let's be familiar also with fractions. So half, of course, that's one half. Thirds, we would have one third. So for one fourth, we can say fourths, but in usually like in American English or other Englishes, they use quarter. So when we mention the word quarter, please be familiar that it is pertaining to the fraction one fourth. All right, now let's make phrases and or I will be presenting to you phrases, and then later on we'll have sentences in English, and then we would be converting this into the mathematical expressions. So the first one, we have 3 added to twice x, or we also have twice of x increased by 3. So 3 added 2 twice x. So he 3 gindugang kan x. Sorry, he 3 gindugang kan twice x. So how we would write this? He 3 gindugang kan twice x. The second phrase, we have twice of x increased by 3. So that is also pertaining to the same thing. Now let's look at the next phrase. We have 4 times the sum of x and y. So we are multiplying something. So we are multiplying 4 to the sum of x and y. So please note, we are not multiplying 4 just to x. We are multiplying 4 to the sum of x and y. So we multiply 4. So we multiply 4 to what? To the sum of x and y. So when we say sum, we are adding, and what we are adding here are x and y. So we do now, since the use of x and the multiplication symbol is it becomes confusing, no? So we can just rewrite this as 4 and then just have it side by side the parentheses. So again, that means 4 has been multiplied to the sum of x and y. Now let's look at the next phrase. We have twice the square of x, then decreased by thrice x. So we have decrease here, so that would imply that there is subtraction. So what are we subtracting? So we are subtracting twice the square of x. So the first one, we have this. So this is the minus part, and then we have thrice x. So twice the square of x. So we multiply by 2. What do you multiply by 2? The square of x. So we multiply by 2 the square of x. And then it is decreased by thrice x. So thrice x, of course, would be 3x. And so those are our how we would write these phrases into mathematical expressions. And there you have it. Okay, now, of course, in conversational English, we would not usually be using the word X. Instead, we would say a number or a value. So we'll just stick with a number. So now let's have the first phrase. The product of two numbers increased by 5. So now we have two numbers. So if we have two numbers that are unknown, then it is imperative that we would also have two variables. Of course, the most common variables that we will be using are x and y. You can use any other um, letters as your variables as long as you be consistent in your usage. Um, Later on, when we would have more examples, we would be reusing those variables. So you need to keep track of which variables you are using. So again, let's go back to the first one. We say the product of two numbers increased by 5. So when we say product, we are multiplying. So we are multiplying two numbers. For this example, I'll be using x and y. So if we multiply, so we can just write xy. And then it is increased by 5, so we are adding 5 to it. So the product of two numbers increased by 5, we can write this in mathematical expression as xy plus 5. The next phrase that we have, the quotient of a number and the difference of 5, the quotient of a number and the difference of 5 and another number. So if you just go through the English terms here, it would be a bit confusing, especially if you do not put the stresses on the significant words. So we need to do a bit of analysis in here. We need to analyze what is being operated, which ones are being operated on, and what is the operation involved. So here we have the quotient of. So quotient would mean that we are dividing something. So what are we dividing? So what we are dividing is a number, and so this is where the division would come in. So we have a number divided by the difference of 5 and another number. So this is, so we have the first number, x, divided by the difference of 5 and another number. So we take the whole difference of 5 and another number. So we will get 5 and another number. We subtract them because it says here difference. Or of course, we can write this. Another way of writing this, we can use fractions. So x over 5 minus y. So they both mean the same thing, the quotient of a number and the difference of 5 and another number. It's just important here that we use a parenthesis because we are taking the whole thing, difference, as the divisor in this quotient. Next, we have half a number is decreased by triple another number. So half a number decreased by, so this means that we have subtraction. So half a number, so I'll do 1/2. So a number, so I'll just use x, and then another number, triple another number, so I'll do minus 3y. And finally, we have cube of a number increased by quarter of the sum of the number and 3. Okay, so we have cube of a number. So first, let me focus on our articles here. So we have here a number, and then here we have the number. So by using the article the, so this means that I am pertaining to the same number. So I do not have here two unknowns. I'm only pertaining to one unknown number or just a single variable. So cube of a number, so that would be x cube increased by, so we have an addition there, quarter of, so again, when we say quarter, we have one fourth, so one fourth of the sum. So we have an addition here. We will get one fourth of whatever we add. So we need to put a parenthesis there. So what are we adding? So what we're adding is the number and 3. So when we say the number, so I am pertaining to the same number, which is x and 3. So this is how we write in mathematical expression, cube of a number increased by quarter of the sum of the number and 3. All right, next we have, so this time, earlier what we have, these are just mathematical expressions. These are considered as phrases. So this time what we now have are mathematical equations, and this would be considered as sentences. So um, in your English, you would know that sentences would convey a complete thought, whereas a phrase does not have a complete thought. So, for example, we have the cube of a number increased by 5 is equal to 5 folds the sum of the number and 3. So, in this part here is equal to, so this is the part where we will write the equal sign. So, everything that comes before that will be the left hand side of the equation, and everything that comes after that is the right hand side of the equation. Okay, so we have the cube of a number increased by 5. So we take this as our left-hand side of the equation. So let's write that first. Cube of a number increased by 5. So that is an addition. We are adding two things. What are we adding? The cube of a number. So we have x cubed increased by 5. So we add 5 there. And then it is equal to 5 folds the sum of a number of the number and 3. So we are pertaining to the same number here. And we also have 5 folds, so we are multiplying by 5. So what are we multiplying by 5? The sum. So we are adding, what are we adding? The number and 3. So we write that there. So let me just rewrite it here so it will be neater. So we have that. Next, we have the difference of a number and 10 is equal to the ratio of 7 and the square of another number. So by use of the word another, then we know that there are two numbers in this sentence. Okay, so we have here the equal to parts. So let's now tackle the first part, the left-hand side, the difference of a number and 10. So difference, we are doing subtraction. And what are we subtracting? A number and 10. So we simply write x minus 10. And this should be equal to the ratio. So if we say ratio, we mean division. What are we dividing? 7 and the square of another number. So I will do 7 over the square of another number. So I'll do y squared. Next, we have the sum of two numbers is equal to half the first number subtracted from twice the other. Okay, so again, let's allocate the equal phrase. So it's there. So the left-hand side of the equation, the sum of two numbers. So we are adding two numbers, and there's no complication in them. So what we just write there is x plus y. And this should be equal to half the first number subtracted from twice the other. So subtracted, of course, subtraction. What are we subtracting? So we have half the first number. So the first number here is x, so 1/2 x subtracted from twice the other. Now, because we have the word from, the other, twice the other should come first. So we move this half, so we do minus 1/2 x there. So what comes first? Twice the other. So we should have there 2y. So this is how we write the sum of two numbers is equal to half the first number subtracted from twice the other. Now let's go into order relations. Familiarize yourself or reacquaint yourself with the inequalities. So we have less than, greater than, or in math we say this is strictly less than, strictly greater than, and then the we would have the less than or equal to and the greater than or equal to. So if I write this, then I can think of it as a number that is less than 5. So x less than 5, we just say a number less than 5. If we have this one, we can say that this is a number larger than, so I'm using an adjective for greater, I'm using larger, so a number larger than 3.14. Now let's have the inequalities that also have equality in them. So for this one, I have my variable, I'm using the word weight. So weight less than or equal to 80 kilograms. So this is how we would usually read this. The weight is less than or equal to 80 kilograms. So there are other ways that we can express this mathematical expression. So we can say the weight should be 80 kilograms or less. And we now use the word maximum. So this would also mean the maximum weight is 80 kilograms. So when we say maximum, no, this is what that is the biggest number that we would accept. You would accept 79 kilograms, 79.9, 78, 78.5, 79.5. You would even accept 60, you would accept 20, anything that is less than 80 kilograms. So again, please note that is how we interpret maximum. Maximum, that is the biggest acceptable value. The last phrase that we have here, or the last sentence, we can say at most 80 kilograms in weight. Now, if we would have the reverse, we would have the greater than or equal to. So the usual way that we would read this, age is greater than or equal to 18 years. So in conversational English, we can say the age is 18 years or older, or we say the age should be 18 years or more, or we say the minimum age is 18 years, or we say at least 18 years of age. So this would be the inverse of the maximum and the utmost. So what we would be accepting here, 18 is the lowest value that we would accept if we say minimum or at least. So you would accept 19, 20, 21, and so on. You can even accept 18.5 if you have such ages. So again, what I want to emphasize here, please be mindful when we have the terms maximum and at most, minimum and at least. I have seen a lot of even professionals who would mistakenly use maximum, at most, minimum, at least. Now we can also concatenate these inequalities that we have. Usually, this would mean that we are accepting a range with an upper and lower bound. So, for example, in this one, the weight is between 80 and 70 kilograms, but we do not accept 70 and 80. So it should be more than 70, but less than 80 kilograms. So you can accept here 70.1, 71, 72. You can accept even up to 79, 79.5, 79.9, and so on, as long as it would not reach 80 and will not also go down to 70. So everything in between except 70 and 80 themselves. So the second one here, we have 70 kilograms less than the weight, and the weight should be less than or equal to 80 kilograms. So we will accept 80 but not 70 and everything in between. So we can say the weight should be more than 70 kilograms to a maximum of 80 kilograms. On the other hand, this third example that we have, The weight should be more than or equal to 70 kilograms but less than 80. So on this one, you would accept 70, you would not accept anymore 80. And we have this. The weight should be more than 70 kilograms but less than 80 kilograms inclusive. So when I with that word inclusive, so that means we also accept 70 and 80 themselves. I can also use the term at least 70 kilograms but not more than 80 kilograms, or the minimum and maximum weight are 70 and 80 kilograms respectively. So this will be the part one of how we would be discussing the discussion on mathematics and language. I'll be sending another video for the next part.